All right, and welcome everyone to this session. Hopefully I can help instruct you on some things about the Inspire. My name is Mark Thomas, and I teach in Oklahoma, actually, at a STEM academy where I teach AP Calc, AP Physics, AP Computer Science Principles, as well as digital electronics. So I'm going to go ahead and share several things that I know and like about the Inspire calculators. Just as a little statement here, I do not work for TI. I've never been paid by them. I don't get products from them other than what I purchase. I just really happen to like the Inspires as well as a lot of their other products as well. So as we go through this, I'm going to go ahead and record this so that way several people were wanting access to it later, and so it'll be recorded. We do have people from a wide variety of places, from the East Coast to the West Coast, way down south and way up north. So that's great. So here's what I hope to be able to accomplish today. I hope to be able to show you some of the basic features of the Inspire, as well as why I see it being dynamic as well as interactive. I kind of see those as a little bit different. I posted this actually in the AP Calc Facebook page, and so I'm definitely going to show some of the AP Calc requirements of how to find, solve an equation, take a derivative at a point, looking at definite integrals. And then a couple things to keep in mind is it's not an 84. So many people really, as we go through this and I try to explain what the Inspire does, many old teachers like myself would lament that, well, on my 84, I knew how to do it. And my suggestion is throw away your concept of what an 84 was as you're trying to learn the Inspire. Think of it as a computer. So Control C will copy, Control V will paste. You can undo, you can escape, file structures, all of that sort of stuff. So my suggestion is think of this actually as a computer. And whenever I hand it to students, they readily take it that way. And they really have no difficulty in trying to figure out some of those pieces along the way. So probably a variety of people here. Some of you all are experts and may be able to even learn a little bit from you all along the way. Some of y'all are kind of in the beginning stages. Some of you all never used one at all. Some of you all may be here because you're curious or your students use them, but you don't, and maybe you just need to learn a little bit about it. That's great. And then I probably have some people in here who are fighters who are saying, you know, it's not as good as my 84. And we'll see how that plays out along the way. I will say this, every year that I teach, and I use the Inspires in my classroom, I do have students in my AP Calculus class who resisted at the beginning, and they continue to use their 84. And then along the way throughout the year, they start coming around to it and they're like, wow, this is really good, really quality calculator. I like the features that it has and the way that it can be done. But if you are trying to remember that menu 4.7 did something, it's not the same thing as it is on the Inspire. So that's just something to be aware of as we're going through this session here. All right, a couple things. First of all, I'm using the Inspire CX2 emulator here. There is a CAS version of this as well. CAS stands for Computer Algebra System. So if you are looking at the CAS version, then you can solve an equation with multiple variables for one variable in terms of others. It will factor expressions. So that's what the CAS allows you to do. The CAS is allowed on the AP Calculus exam for the portion that you can have the calculators available. However, it's not allowed on the ACT exam. And the ACT is what we use here in Oklahoma. So for that reason, I encourage my students to not get the CAS version, okay? The CX version itself, or the CX2 version, is fully acceptable on the ACT as well as AP exams. Okay, so a couple things here that we're going to go through and try to just share with you what it does. So I'm going to start from the very beginning. We have a screen here. And so whenever I hit the home button, which is how a lot of times it comes up, then I have some options here. You'll hear me say this several times. I would stay away from Scratchpad. You could calculate and you can graph, but it does not have the interactive features that will be used if you will just use the things down at the bottom. They're much more powerful. for you. So I tell my students, stay out of Scratchpad, stay out of Scratchpad, stay out of Scratchpad. So that's what my big suggestion is, that you grab hold of right here at the beginning. Some of you all may have an Nspire in front of you and you're going along with us, that's fine. Since we're not face to face, I can't look over your shoulder to see what was wrong. So if at some point you start to get lost, if you're trying to actually manipulate in the same way that I do, then you might just sit back and watch. One of the things may be that you're trying to find out what it can do, so then you can understand how it can happen. And then some of you all already know how to manipulate things and you're just trying to figure out some additional tools. So whatever you take away from that, that will be great. So here's a couple things we're going to do. I'm going to go ahead and jump into my calculator screen. So this is my calculator screen that I have here. I'm going to talk about approximating. So first of all, whenever I do 2 to the third, if I want to do 2 to the third plus 5, well, whenever I use my housetop symbol here, I'm in the exponent, and now I need to come down out of that power. Couple things as far as this pad goes. It is touch sensitive like a laptop would be, but you can also click on them as well. The oldest versions of the Nspires was just a click pad where it wasn't touch sensitive on the top surface. So I'm going to come down out of my power, and then I'm just going to say that plus 5. And then we can hit enter down here in the bottom, and there's our answer, okay? So we're really excited that we are able to do something like that. Let's keep going along. I'm going to take a look at approximating. So I'm going to take a look at the fraction 2/3. So whenever I type in 2 and then divide, this division symbol here, 3, and what you'll notice is it spits back to me 2/3. So it's in an automatic feature mode where it's trying to reach exact values when possible, as well as approximations when needed. So what we have is a couple of ways of forcing it to give me a decimal answer. First way that I can actually force it to give a decimal answer is if I actually put a decimal point in my calculation. So if I do 2 point divided by 3, now when I hit enter, it actually gives me that decimal approximation. Another way that we can approximate is whenever we 2 divided by 3, and this is what I usually try to train my students to do most of the time, is right above the enter sign, there's an approximation symbol. So if I hit control and then enter, then it will force it to be an approximation. So that's how I try to get my students, if you're looking for the decimal answer, make sure that you do that. So that's just kind of getting started on some of the different parts that we have. I'm going to walk us around our board here, kind of explaining some of the different pieces that we have. Over here on the right-hand side, the home button takes you to be able to add in different functionalities. We'll see some of that along the way. We can look at document settings. This menu button will pull up whatever menu is appropriate for that situation. So if I'm on a graphing screen, it looks like to be a very different menu than if I'm on a calculator screen. So that menu will pull up the appropriate menu that you need. We can escape. You'll hear me say this a couple of times. If you are doing something and you want to stop doing it, hit the escape button. That seems to be the best way to take care of that. The tab button works as it would on a computer. So if I have different fields that are open that I'm trying to manipulate around a page, if you just hit the tab button, it'll cycle from one field location to another field location. On the left side here is a lot of our functionality that I would say that we have, our computations. In particular, you don't have separate sine, cosine, tangent buttons. They're all hiding inside of this trig button. You do have your exponentials and logs and their inverse functions. And you have not only the open and close parentheses, but other types of parentheses as well in blue right above them. We'll use one of those here in just a second. You have this pi button here, which is more than just pi. And so this is a place that sometimes people forget is available. So if I hit the pi button, it actually allows me to put in imaginary numbers or the natural number e, or maybe force things in degrees or radians mode. So that's just some of the functionality that we have there. Again, I have this on my screen now, but I didn't actually want to add anything. So if I hit escape, it backs out of that. So that escape button really helps. So we're going to go through a few other pieces here on just some basic things as we move forward. One thing to note is if you use your up arrow and we go up and highlight something above, then what we can actually do is we can then hit enter, and it will copy down whatever expression or part of an expression that you have, and it will copy it down into that command line wherever you were. So instead of having to type in 2 divided by 3 again, I can just simply go up, have it highlighted, and then hit enter. It'll copy it straight down for us. I'm going to store this into a variable because a lot of times that'll be useful for us. The store feature is right above variable. So I'm going to hit control first, then we'll store. And I'm going to store it into the variable A. So I'm just going to type in A on my alphabet down here. Little side note on that. The alphabet is in order because if it were a QWERTY keyboard, then it would be considered a computer under the original days of trying to decide what's a calculator versus what's a computer. Funny thing is they've just left them that way, although this is definitely a computer, although it's allowed on tests and state tests and things like that. All right, so I have this variable and it is the value of 2/3. So if I wanted to take 5 times that value, then I could just say 5 times A. And one thing I'm going to point out is whenever I hit this A, it is going to now look bold. Anytime you're typing something out and it goes to bold, then what it's saying is that it recognizes this thing from something you did before. So whenever I do 5 times A and hit enter, it'll compute that for me. However, if I did 5 times B, I haven't put anything in B yet, and you'll notice that it's italicized still. It doesn't recognize B as being anything. So that's just something to keep in mind whenever you see that feature and you're expecting to be able to use it in some way. All right, I'm going to take a look at our list feature. This is one of my favorite features that we have that's available. And so if I have a list, and I'm going to take, to create a list, it is the squirrely brackets, the ones that have the pointy in the middle there. And I always have a hard time trying to see them on the calculator. So I'm going to take control right parentheses. So it's this set of squiggly brackets that's above it. That's control right parentheses. And I'm going to just create a list of this. So I'm going to say 5, comma, if you're looking for the comma, it's this one down here, 6, comma 7. I'm going to right arrow over it. And I'm going to store that into B. So now if I just type B, it recognizes that I've stored that list in there. Suppose I wanted to multiply the A value that I had before times this B list. Well, if I type in AB, when I type in A, it goes bold. Whenever I type in B, it's now all italicized. Here's a big thing about the Nspire. The Nspire allows you to use a string of letters to create a single variable name. So what that means is right now this Nspire is saying you're trying to talk about the variable ab rather than the quantity A times the list B. So what I need to do in order to make sure that it understands me is I actually need to put in a multiplication in between them. So let me say that again. If you are trying to use a string of letters to multiply, the Nspire is going to create that or interpret that as a single variable entity. So I could have stored this list right here under the name height, and it would have treated HEIGHT as a single quantity. So there's our multiplication, and we'll see what happens. And sure enough, it took that list and multiplied it by 2/3 that we had there. All right, let's take a look at what's going on with graphing. So I'm going to go ahead and head to the home screen, and I'm going to add a graph. Notice, as I said before at the beginning, I'm not going to add the scratch pad graph. I'm going to add just this graphing screen here. So we have calculator screen, graphing screen, geometry, lists and spreadsheets like an Excel sheet, data and statistics, a notes page, and then a way that we can actually add probes to and connect them to our Nspire calculator that we have. So let's take a look at a graphing screen and see what actually happens here. So I'm going to take a look at a basic x squared graph. If this window, entry window, is ever not seen, and we'll see that here in just a minute, if you hit the tab button that we talked about before, it'll open that up for you. And you may have to hit it a couple times for it to cycle through. There's other ways to get that to open, but that's a way to get that open. All right, so I'm going to go ahead and do x squared. So I'll do x squared. And then whenever I hit enter, of course, it will graph that for me. All right, great. You can do that on a lot of different calculators. But what I'm going to do is, if I were actually using a physical calculator, I'd be swiping this swipe pad right here. And as I swipe close to it, you'll notice that it actually gets this type of symbol. If I swipe close to the vertex of it, it will actually get a plus symbol, okay, a move symbol. So I can actually take this graph that I entered and then slide it left or up or right or down, and it automatically is updating that equation to show what the new equation actually is. Okay. If you're doing that and it's still doing it and you can't make it stop doing it, then definitely hit the escape button, and that escape button will let go of the action of moving that you had. Okay. I want to point this out because it's a little easier for me to do on the computer than it is actually on the calculator itself. When you swipe over to where we were, in order to grab hold of things, you're going to use this center dot. I just call it the center dot button that we have here. You can either press and hold the center dot, you can double tap the center dot, or you can hit Control Center Dot. So once you get your cursor to where you want, you have those three options of grabbing hold of it. Control Center Dot, double tap the center dot, or press and hold the center dot. All right. The other feature that I could have done here was on the edge of this graph, I could have grabbed it and widened it. I'm just grabbing it and then pulling out, or moving it in, or maybe even making it open upside down. And in all of that, it's constantly updating what the equation actually is there. Again, to let go of it, hit escape. If we want to be able to utilize the window in a different view, so maybe, for example, I had it so far up here that I really needed to look at a different window setting. There's several ways of doing this, and you'll hear me say that over and over again with an Nspire. There's several ways of doing almost everything that we have here. So one way that I could actually do it is just grab the background, the sheet background right here, by either pressing the center dot or double tapping or control. When I grab hold of that background, then I get this little fist symbol here, and then I can actually swipe it down, swipe the control pad down, and just move it around to wherever I want to move it. Okay, so that's one way that we can do it. Another way that we can do this is if you told me what particular window we wanted. So maybe I wanted this from -10 to 10 and from 0 to 20 or something like that. Over here, I can change this text. So whenever I click on this, and I will point out, this is one of those trial and error things. You'll get good at it after a while. Sometimes it's a double tap. Sometimes I press and hold it. It's just kind of one of those where you mess with it enough that you can actually get in here then and type inside that box. And I'm going to change it to -10. And when I hit enter, it automatically adjusts the left edge of my screen to -10. I can come over here, swipe all the way over here to the right edge, double tap. Maybe I want that to be 10 now. And maybe I wanted this bottom part of my window here to be 0. And so I'm only seeing the top half of the plane there. And you could change any of them that way. We can also zoom in and out by grabbing the axes. So you'll notice that as I'm moving around, when I got close to it, my hand turned sideways and it says, do you want to grab hold of those axes? I can actually grab hold of the axes again by either doing the center dot, control dot, center dot, something like that. And I can grab those axes and move them, and I can push it toward the origin. And so what I'm actually doing now is I'm pushing it, shrinking it down toward the origin. So I'm actually zooming out. And you can do that with the vertical axes or the horizontal axes. And you'll notice that actually what it's doing now is it's zooming in both directions simultaneously. Okay. So you can grab hold of the axes to zoom them. You can go into the menu setting and set up your window settings if you wanted. So if you wanted to do it kind of the way that you would have done on an 84, you can absolutely do that as well. If you've pushed in there and you're ready to back out of there, you can hit escape and you'll back out of those menu selections that you had there. Good. I'm going to go ahead and reset this one down below a ways. Well, I'll just turn it upside down here. And we'll move it over. And I'm going to graph another graph here. Notice that I don't have that entry window here. If I hit the tab button, it'll actually pull it up to where I can enter it. So I'm just going to, this f1 of x is no longer x squared. So I'm going to put in f2 of x as x squared. And now I have this nice little thing going on here. Okay. And if you have the color versions of the Nspire, so the CX is the color version, then you'll notice you have the ability to have multiple colors here that are available. So I now have these two here. And one of the things that we want to do in our AP Calculus class in particular, and I would say argue in any algebra class that you're teaching, is you want to be able to find intersections of graphs. You want to solve an equation. So one place that you can actually do that is right here in the graphing screen. So whenever I look at this, I don't really have a solve button anywhere. It's all under menu. So I'm going to go into menu and I'll come over here and I can look underneath actions. There's some different options that we have here. We have some different views that we can set up. But what I'm actually wanting to do is right down here on, it's actually number 6 on this, analyze graph. And I want to look at an intersection. So you'll notice there's a lot of features under here under analyze graph. Maybe you're looking for the zeros of the functions, mins and maxes. And then on the calculus side, you can take the derivative at a point here, and you can do a numerical integral here as well. So I'm going to go ahead and choose the intersections part here. And this is where on the computer, it's easy because I can just use my mouse and go left and right. You can use the swipe pad that you have here to swipe it left and right. Or this is one of the things I think that's really cool about this. I'm looking at that graph, and if I'm looking for the intersection that's right about here, then I can see that that intersection is between -0.8 and we'll say -0.4. Okay. Well, it's asking a question in that bottom left corner. It says, what do you want the lower bound to be? I can tell what the lower bound is either by clicking on the graph in a certain location or by typing in a number. And as soon as I start to type in that number, it will automatically give me a box that I'm typing in. So negative 0.8, and I'll hit enter. And then, oh, that did not work quite like I thought it would. Let me escape back out of that. We'll try that again. I'll hit menu, analyze graph. We'll do intersection. I'll have the lower bound to be negative. We'll just do -1 and hit enter. And I guess that's farther left than I thought it was. We'll try that again. Analyze graph, intersection. We'll do -2. So there's the left edge. I guess that's not where I thought it was. And then it asks for the upper bound. So again, the upper bound, I could put in 0 because I'm pretty confident now that it is between -2 and 0. And it's giving me an intersection. Okay. Please listen carefully if you teach AP Calculus. You have to give answers, the final answer, to 3 decimal places of accuracy. Okay. One is it's kind of hard to see here. So what I can do is I can grab this text. So I'm hovering over it. I grab hold and I can move it off to the side to where I can actually see what's going on. This X intersection is not to 3 decimal places of accuracy. And I might have to use that later in the problem, and it might cause compounding errors. So in menu, I can change the settings. Now be careful on this. This is the settings that are associated with the graph screen, not the calculator screen. I'll show you that when we go back to the calculator page here in a little bit. But I'm looking at the difference between setting up the display digits here on the graphing screen, which is a separate setup than it is on the calculator screen. So I'm just going to change my float digits here. You know, maybe 12 of them will be enough. Surely that'll be enough. And then you can see now that I'm getting plenty decimal places of accuracy there. Okay. And again, where do you go to look for it? I don't know. Go to menu. More than likely, you're going to find what you need on a particular page to manipulate something in the menu button. All right, so that's what we have there. By the way, if we did move one of our graphs around, then it is going to update everything all along the way as well. So just be aware that that's actively happening along the way. By the way, I do see now what my issue was. My X tick mark here was 1. My Y tick mark here was 0.5. I was reading this as a -0.5. So something to be aware of there with that. All right, something else that you can do on this is you can actually be able to evaluate a graph or trace a graph along the way. So if I look for menu, trace, graph trace, okay? So I went menu, trace, graph trace, and it's giving me the F1 value here below. We could change it to be the F2 value, but as I step to the right, so I'm just clicking on the right button here. So as I step to the right, you'll notice it's going to go to 0.219, 0.3, 0.6, 0.9, 1.2. And so one thing that you might need to know is I actually want to know what is this blue function evaluated whenever X is 1. But it skipped right over it. I'm in menu trace, but it's only set up to go right now every 3/10, it looks like. Inside of menu trace though, if I just hit the number 1, it opened up a text box for me. And when I hit enter, it jumps and evaluates the function at exactly 1. Now, one thing you'll notice is I'm still in graph trace. Here's the graph trace feature. I'm still doing graph trace. So if I wanted to evaluate it at 1 and then evaluate it at 2, I'll just type in 2. It pops open the box for me. It jumps to whenever X is 2. It updates the value down below as well. So that's just a feature that you have. There's other ways, again, of evaluating this. I'll show that in just a minute. And one of the things that can be tricky along the way is I'm done tracing the graph. How do I stop? So I'm going to show that here in just a minute. By the way, you might have noticed whenever I came across that 0, it found it for me and it said the word 0. So even though it may not be lined up exactly with the every 3/10 evaluation, it actually tried to go, oh, you know what, you might be interested in this point right here. It's interested in it being the 0 value that you have. Okay, I'm done tracing. I want to stop. So we always hit escape. And when we hit escape, you'll notice that symbol there goes away. It says, okay, we're done. We're done tracing. We don't need to trace that anymore at all. All right, let's go back over to our calculator. So I'm just gonna, right here at the top, these are different tabs. And so I can go back to the calculator that I had open, or I could technically open other calculators along the way. But if I just swipe up here and click on this, it will take me back to that calculator page that I had. Now, my function that I had before for F2 was the x squared function. And so if I want to evaluate x squared at, let's say, 5, 6, and 7, well, let's do it at 1, 2, 3, 4, and 5. Let's say I want to evaluate a function. So when I type in f, it's italicized, but when I type in the number 2, it goes to bold and it says, I recognize that we've done something with this before. And what you'll notice is that it's actually the other page. It's the graph page talking back to this calculator page. Again, this is one of the reasons why I say stay away from Scratchpad as much as possible. So if I want to evaluate that function at, for example, 3, then f2 of 3 is 9. And if you remember, the f2 function that I had was the x squared graph. But my teacher was mean, and they said that they wanted a whole bunch of values, and I don't want to have to keep doing this over and over. So I can type in f2, open parentheses, and then open a list. So right here, Control right, opens the squiggly brackets, and now I can put in 1, 2, 3, 4, 5, and when I hit enter, it automatically plugs each of those independently in and then returns the value of the list. Again, lots of other places that we could have done that as well. On this page here as well, if I never wanted to use the graphing screen, if I just wanted to say on this page, I could actually create a function, and maybe that it's the height of something. So I can actually create a function here under menu, under actions, define. Actions, define. By the way, if you're peeking ahead, there's a whole bunch of stuff we can do here under menu. So menu, define, and then I'm just going to type in height, H-E-I-G-H-T, of x, and then I need an equal sign, not the enter. So I'm not doing enter, I'm not doing approximately, I'm doing the equal sign, which is right here below the control button. So I'm going to say equals. We'll just do simply x plus 1. Okay. And then whenever I hit enter, it just says done. But I can now actually type in height and it goes to bold because it says, hey, I recognize you. And I can say, well, what is height of 7? Well, height of 7 will be 8. We could even do compositions of functions. So what is f2 of height of 7? So this should be f2 of 8, which would be 64. Okay. So lots of different things, uses that we can do there in our function list that we have. I do want to point out, as I said before, when you're doing trig functions, you'll notice right here I have it's in radian mode. It actually displays it always, so you'll know which mode you're in. If you want to be in the other mode, if you click that button, it'll toggle it back and forth between radians and degrees. This mode does not affect your graphing window. Your graphing window is usually defaulted into a radian screen. But if you wanted to change the graphing screen to degrees, you could do that inside of the settings in the graphing screen. Okay, so I'm on a radian here. And so if I want to find the sine of something, if I type the trig button and then I hit the sine button, that's one way that I could do it. And I could say, well, what is the sine of 1? And then we get the 1 radian, so not 1 degrees, 1 radian. Then we get the output of that. But if for some reason I had something where I wanted to take x times the sine, you'll notice it's all italicized because it's treating that as one variable. And this is where I see a lot of students get in trouble, is they try to do something like that. If I want multiplication to occur, then I actually need to put a multiplication symbol if it's between letters. Otherwise, it tries to make it be an actual single expression, okay? So just like height is a single expression, it's not reading it as multiplication of all of those letters. Similarly, if I did even a times sine, it's reading that as an italicized thing, not the value of a that I had times the sine of something. Okay, so just be aware of that, be careful on that. All right, we are going to jump over to lists and spreadsheets. I'm just going to do a quick little thing with some statistic stuff, not heavy statistic stuff, just regression stuff, maybe is the best way to say that. Whether it's an algebra class or a calculus class or any of my classes that I do, I always show this functionality on it. And so what I can do here is I'm going to go in and I'm going to, and you can either do this from the home screen or something else. I'm going to add in a list and spreadsheet. And one thing to be very careful of, I want to name them way up high, and then I'll enter my values here. So I'm just going to quickly make up a name here. This is he. This is haw. Yes, I'm from Oklahoma. And I'm going to put in some values here. So I'm just going to quickly go through 1, 5, 7, and 9. And then I'll put in some values here, 2, 5, 18, and 22. The place that's right here is reserved in case if you want to enter an equation that would then allow it to be computed, a computed column, rather than just a variable name. So make sure you're not entering something here. But if, for example, I wanted to have a third column and I wanted to say that I want it to actually be 2 times he, then I could put it there. I just put equals 2 times he, and then it'll automatically double what he was. Okay. So I have this set of values here. I think it's linear, somewhat linear. We're going to take a look at this and see how linear it actually may be. So I'm going to jump in here and I'm going to go through and enter in from here. I'm going to go home and I'm going to go to data and statistics. So this was the list and spreadsheet that we were just at. I'm going to do data and statistics. This is not the data set that I had. It's just a couple dots holding some values on the screen somewhere. What you'll notice is down at the bottom, if you swipe down to the bottom, it'll say click to enter or enter to add a variable. So if you click that spot, I'm going to put he on the x-axis. Magic happens. I'm going to swipe over to the left edge and I'm going to put haw on this one. And there's my data set. And similar to before, you can manipulate it to where you can zoom things in and out on the axis if you want to grab hold of and so forth. All right. One of the things I think that's really cool is when we tell students to do regression, a linear regression, most of them don't know what that is. They understand it's a phrase, but they don't really know what's going on with it. Without going through all the computations, I'm going to show visually what's happening with this. So I'm going to go in and I'm going to say menu. By the way, I usually only do this once for students just so they have the experience with it. So I'm going to go in, I'm going to say menu, and I'm going to say let's see, it is under Analyze, and I'm going to say Add a movable line. Okay, this is not the linear regression model. Okay, but I could move this around by grabbing the center or grabbing the edge and tilting it. Well, how would I know which one is going to be the best? So I'm going to add something to this setup here, back under menu. So I just went to menu and Analyze just a second ago, and I added a movable line. But now I'm actually going to do residuals squares. And so what residual squares is it shows a square of how far off the point is from the data on the line, for the location on the line, and represents that visually with a square. And so I have these 4 squares. This one's really big. These 4 squares, and if you add up the areas of those squares, you're sitting at almost 75. That is the sum of squares. And so we're going to minimize the sum of squares, which is the least squares method that we have when we're doing this. And as I move this around, you'll notice, hey, this down here looks a little bit better. Does it need to be tilted a little bit more maybe? Maybe I need to tilt it a little bit more this way or some other way in order to get a better fit somehow out of this. Okay, looks to me like maybe sum of squares that I can best get is somewhere around 40. Right, that I think helps students understand when you're looking at this. This is what the calculator's doing behind the scenes. Now they're not actually drawing the squares; they have computations and stuff. But we're trying to minimize the sum of squares. So maybe I have them record this equation, and then I say, okay, let's see how close we were. So I'm going to do menu, Analyze, Regression, and I'll do linear. And if you're a math teacher, you choose the mx plus b. If you're a stat teacher, you choose the a plus bx. Okay, so I'm going to do mx plus b because that's my world. And then here is the equation, the best fit equation that we had there. Okay, and so you'll notice that this is my movable line. We were really close to being the best possible that we had there. Okay, this is the one I'm grabbing hold of right now is actually the movable line that I had compared to the equation that it had. And so you could go in and actually compare those and see how close were you. And gets to be a bit of a competition between students on who can actually get the least sum of squares that you have there. Okay. I'm going to jump over to a little bit of geometry just so you see what's possible with it. If you've ever used GeoGebra, Desmos, Geometer Sketchpad way back in the day, this will look something familiar. I went under menu and I told it to draw a shape that was a triangle. I clicked on the points. I constructed the perpendicular bisectors by that command underneath menu as well. I found the intersection of those points. I drew a circle centered here through a point. I went ahead and told it to measure all of the angles. And now I have the ability to grab hold of one of these points and move it around. And as I move it around, what you'll notice is, and if you've done much with geometry, maybe you've already done this in your classes with other platforms, is it's always updating everything, the angles included, as well as showing that these 3 points are always on this circle, with the circumcenter being the location of the intersections of the perpendicular bisectors of the sides of the triangle. And then you can ask the questions of, okay, so when is it that the center is outside the triangle? And the answer is if it's obtuse. When is it inside the triangle? And then when is it on the triangle? So if it's on, it's right angle, right triangle. If it's inside, it's an acute triangle. Okay, so that package is there as well. Again, to get to that package, you would just go to Home and open up the geometry setting that you have there. All right, I'm going to go back and I'm going to show you another piece here because I've actually set mine up this way a little bit. So I'm going to go back into my current thing that I have here. What you'll notice is these 2.1, 3.1, 3.2, these are different problems. So tab 1.1, 1.2, and 1.3 will all talk to each other. When I get over here into tab 4, problem 4 has no understanding of what was going on back in problem 1. And so problem 3 has no understanding of what was going on in problem 1. So much so that if I take this and I try to do a function value of a certain point, you'll notice that didn't turn bold. It doesn't know what F1 is. It doesn't know what F1 is because I created it as a different problem set. So your different problems don't talk to each other. So if you want to use F1 multiple times, you could actually just create new problems along the way. So let me show you real fast how to do that. Jump over here. When I go Control up, I see thumbnail sketches of all of the pages that I have open. And one of the things I can do now, again under menu, is tell it to insert a problem. So when I insert a problem, here's a new problem. So this problem won't communicate with any of the other problems that we had above. All right, so let's go ahead and work on a few other pieces here. Y'all doing a great job sticking with us, by the way. So I appreciate y'all. We're going to take a look at matrices and then also some calculus things that we have and some locations and where we can find them. So one of my more favorite places to go to is right over here. There's a variety of things that we can utilize. And so one of them is right above the division symbol is a fraction bar. And so if we want to, let me add a calculator screen here. If we want to, I could actually, instead of using the division symbol, I could do Control fraction bar, and now I can do 5 plus 7 to get down to the bottom of it. I can just hit the down arrow over 2. Very difficult stuff we're doing here, and I get the magic number 6. All right, so that's a place that students frequently end up really liking to find. If we look to the button, this is the book. I'm not pushing the book button yet. I'll show you that in a second. The button that is immediately to the left of the book has a variety of things here. All right. So first of all, if it has this symbol, that means it's not available to us. And the reason it's not available to us is because it's not a CAS Inspire. It lacks the computer algebra system. One of the things I really like about the Inspire and the Inspire CAS is the layout of all of it is the same. So if you can use an Inspire and I give you a CAS, you automatically know how to use it. It just has more features inside of those menus available. So that's a big thing. Unlike whenever they jump from the 84 to the 89 was a completely different animal than what the 84 was. You had to completely relearn how to use all of it. So this is really nice because whether they're using an Inspire or an Inspire CAS, they can use them very much the same way. Matrices are really nice to use here. So if I want a 2x2 matrix, I would just hit this button. If I want a 3x3 matrix, I'll hit this one. I'll just take the 2x2. And when we can just fill in our values here. And so I really like this ease of use compared to the 84. On the 84, you had to go in, you had to name it, then you had to go in and create it, and then you had to pull in the names from a different little sub menu and stuff. And right here, I don't have to do any of that. If I want to take this and take the inverse of this matrix, then I'm simply going to raise this to the power of -1. I believe this matrix is invertible. And then maybe I would want to multiply that. So I'm going to hit a time symbol here. I'm going to multiply that again, the button beside the book, and I'll do this matrix right here, and we'll say 2 and 3. And so there we go. So very easy to use with the matrices, incredibly easy to use with the matrices. Whether you're taking transposes or row reduction or anything like that that you want with the matrices. All right, in the last little bit here, we're going to summarize a couple calculus features that we definitely need to know, especially if we're doing AP calculus. So we already talked about how you can use a graph to find intersections. You can also use the calculator screen to solve equations, which again would be the same as finding intersections of graphs. And so I'm going to show you how to do that. And a place to do that is in the book feature that you have right here. There are other places to do that as well, but I'm going to show you the book feature first, and then I'll show you a couple of other places you could grab it. So on the book feature, it's laid out like this. It's just everything that this calculator can do. Inside the book, alphabetical, everything that's going on. Tab 2, this is a bunch of your different computational things that can go on, okay? And then we go on and on whether we're using different features along the way. So on this one, it's actually a numerical solve. So if I just type the letter N, it jumps me down to the ends, and then I'm going to go down here to Nsolve. So right there is Nsolve. And so the really nice thing about the book feature, which once you get familiar with it, you probably quit using the book feature, but the book feature will always show you the syntax of what's needed down below. Anything that's in square brackets at all, anything that's in square brackets is optional. If it's not in square brackets, you have to put it in there. And by the way, you won't put the square brackets themselves in. It's just showing you what is optional that you have there. So I'm going to solve an equation. So I can actually click on this and it'll insert Nsolve for me. And let's say that I want to solve an equation. And remember, we solve equations, not expressions. So I'm going to solve x squared equals 7. And then this is where students make a mistake. They'll hit enter and it won't work. And the reason is because I have to solve it by telling it which variable, comma, x, the variable I want to use in the solving. It seems silly here because there's only one variable. But if you had a CAS model, I could have X's and Y's and Z's all in this, and I could solve it for any one of those letters. So that's why I have to have it there, comma, the variable I'm solving for. And what you'll notice is it found a solution, but there should be another solution. And so that's what that other option there was. I'm going to go up. I'm going to highlight it. I'm going to copy it back down. And I'm going to come back inside of here, inside my parentheses. I think there's another answer near -3. So I'm going to put in equals -3. And so in that syntax that it showed just a little bit ago, it said in the square brackets equals guess. This is the guess. I think it's near -3. I don't have to hit it exactly. I'm just telling it where to go look. So when I hit enter here, it found the other solution that was near -3. So the nice thing about the graphing screen is, you know how many you're looking for and what kind of near what you're looking for. On this screen, if I didn't know any better, I might think that there was only one solution that you have available there. Also, I don't actually have to go to the menu, but I could. If I went to menu and I went to algebra, there's numerical solve. But I'll escape back out of all of that. If I just typing in Nsolve, Nsolve, as soon as I hit the E, it says, I know what you're talking about. I'm going to stand it upright. It's no longer italicized. And I can just type in the letters Nsolve. Same thing with sign function or anything like that. You start typing in the letters. Once it recognizes it, it stands up straight. So that is one of the features that you have to have. Again, AP Calculus says that you need at least 3 decimal places of accuracy. So if I want to be careful here, then I may go in and actually look at the settings on this, which is actually right here on some of the older versions. There is actually a gear symbol right here as well. And so if I click on that symbol and I look at document settings, I can actually change the display digits here, maybe all the way up to, I don't want to fix it, I'll float it to 12. And then if I wanted to recompute what I just did, I can go up, I'll hit enter, hit it again, and now I have much more than the 5 decimal places that I had before, okay? So that is solving. If I want to take an integral or a derivative, You can do that again inside of the book command. Okay? Or the button beside the book where we were just a second ago, I can do it here as well. So I'm going to do a definite integral first. My definite integral is right here. Okay, if you're looking for it in the book, it's in int for numerical integral in int. So I tell it to do this integral. And the nice thing in this format is it lays it out exactly like I would like for it to be. So I'm going to go from 3 to 5 of my function, and then make sure we put in our variable of integration, and then we hit enter. Okay. And just as a reminder, this is a required skill set that students have. Since I'm in a new problem, it won't recognize any of the other functions, but if I were in one of the older problems, I could actually have invoked the f1 of x that I had before, or the f2 of x that I had before. And I could have just put in f1 of x right here. Okay. That's a numerical integral, 3 decimal places of accuracy in the final answer. So make sure that you're importing as much as you need. If I need to use this expression later, I could actually go up, hit enter, copy it down, and then store that over into another variable. And so then if I needed to use that variable as an integral value or something like that, then I could use that as well. That's a definite integral. We're going to look for a derivative at a point. Again, beside the book, this is my favorite place to use it, is right here. I could actually do a second derivative or third derivative here, but in calculus, AP Calculus, we just are expecting the students to be able to take the first derivative at a point. So I'll click on that, and you'll notice that it says what variable. Okay, we could actually use whatever variable we wanted. So I'm going to put r just for fun. Okay, and I want the function to be r cubed, and it won't work yet because it's not going to tell me 3r squared because this is not a CAS calculator. I'm going to try to evaluate this. So I'm going to use the evaluation bar. The evaluation bar is the straight up and down stick that we have. I actually learned, I think, from Mark Corrali the other day, what it was actually called. I forgot what it's called now. I'm going to put that evaluation bar. It's inside of the equal, but it's control equals. Control equals is where we can find that. It's this stick right here. Okay. So with that stick, now I'm going to evaluate it at r equals, and I'll throw it in at r equals 2. And there we are. So we get 3 times the 2 squared. Our answer is 12. So that's the way that I prefer to do a derivative at a point. Again, you could do it on the graphing screen. You could jump in here and do menu, calculus, numerical derivative at a point, or numerical integral. You can do them there. The way that it asks you in numerical derivative at a point, I don't like the layout of this. That's why I don't use that, okay, under the menu screen. I like going through the spot here beside the book. I think it's more intuitive for students to understand that portion of it. All right. Couple other pieces that we have here along the way before we wrap up here. I'm going to try to keep it right at an hour. If you want to use probes, vernier probes, you could actually go in here and insert this page right here. On the very top of your Nspire, you have that little micro USB. And so you need to make sure it's a probe that works with the calculators. Not every probe does, but you can definitely utilize probeware with this, take recordings, do analysis on it, all that sort of stuff. Create a sheet out of it and figure out, hey, if I throw the ball in the air and it comes back down, can I actually mimic a quadratic that's upside down for it? Okay, so some pieces like that. That's just something else that these will do for us. And then another portion that we have here is, I'm just going to throw this out here because I think it's just really cool. Back on one that I actually made up for us already. I actually inserted sliders. So to insert a slider, you go into menu and then actions, and then it's actually down below here, it's insert slider. And then it'll ask you to name the slider and what you want it to go from and to. And then I put in the equation here. I put in x minus h squared plus k. I've already named the sliders h and k, but I went ahead and put in my expression here. And then after I'd already named my sliders, and now as I grab hold of these, I can actually drag it left and right, and I can actually see what's actually physically happening to the graph with different values of h and with different values of k. Okay, this is another feature that you have there that makes it pretty easy as well. I think if you actually animate it, then it'll actually walk through, and you can step this smaller. You can make it progress by 1/10 instead of a whole unit if you want, and actually just make them then cycle back and forth as you have there. Okay. All right, I'm going to pause there because you guys have done a great job listening for about an hour here. I am going to make this available. I'll capture this recording and make it available, and I'll send that out as well, both on the OK Math Facebook page and the AP Calc Teachers Facebook page for anybody that wants to see it there. So with that, I'm going to stop our recording and stop our share and